You may find it useful to pause this video now and review the question before continuing. Now in this question, we have a population of vehicles, and each member of this population has exactly two features associated with it. The two features are the vehicle's color, red or green, and the vehicle's type, car or truck. For questions involving populations where each member of the population has two features associated with it, we can tackle the question using what's known as a double matrix. Now we can also tackle these questions using Venn diagrams, but I happen to believe that the double matrix method is superior when tackling upper-level questions of this type. So let's begin. One feature here is vehicle type. So we're going to reserve the two boxes in the top row for cars and the two boxes in the bottom row for trucks. The other feature is color. So we'll reserve the two boxes in the left-hand column for red vehicles and the two boxes in the right-hand column for green vehicles. Now the question tells us that we have 80 vehicles in total. So we'll place that information here to remind us of this. Our ultimate goal will be to place each of our 80 vehicles in one of the four boxes, depending on each vehicle's characteristics. So in this box, we'll place red cars. In this box, we'll place green cars. In this box, we'll place red trucks. And in this box, we'll place green trucks. Now the question tells us that we have 35 red vehicles. Now some of those red vehicles are cars, and some of those red vehicles are trucks. At the moment, we don't have enough information to place any of the 35 red vehicles in either of these two boxes. However, since 35 of the vehicles are red, we know that the sum of these two boxes must be 35. So we'll add that here. Now if we have 80 vehicles altogether, and 35 of those vehicles are red, we can conclude that the remaining 45 vehicles must be green. Now some of those green vehicles are cars, and some of those green vehicles are trucks. However, what we do know is that the sum of those two boxes must be 45. Similarly, we are told that we have 60 cars. Now some of those 60 cars are red, and some of those 60 cars are green. So we can't place any of the 60 cars in either of these two boxes. However, we do know that the sum of these two boxes must be 60, since we have 60 cars altogether. Now, if we have 80 vehicles altogether and 60 of them are cars, we can conclude that the remaining 20 vehicles must be trucks. So we know that the sum of these two boxes must be 20. At this point, we cannot say how many vehicles must be placed in each of our four boxes. We only know the sums of the boxes in each row and each column. To fill each box, we now need a seed, and here it is. We're told that we have 9 green trucks. So we can place this information in our table right here, since this box is reserved for green trucks. From here we can complete our table. We are told that the sum of these two boxes must be 45, so this box must be 36. We know that the sum of these two boxes must be 20, so this box must equal 11. And finally, we know that the sum of these two boxes must be 60, so this box must be 24. Now the question asks us to find the total number of red cars. Since this box is reserved for red cars, we know that we must have 24 red cars in total. So our answer here will be B.